Imagine a world hidden beneath the waves, a world of colossal forces and unimaginable scale. Let's journey back to 2018, when the largest underwater volcanic eruption ever recorded began to unfold. Scientists tracking seismic activity in the western Indian Ocean near Madagascar noticed something extraordinary. Between 2018 and 2021, over 11,000 earthquakes rocked a small island region nestled between Madagascar and Mozambique. The most powerful of these tremors registered a magnitude of 5.9. Before this, the area had been relatively quiet, with only 2 earthquakes recorded in the preceding 50 years. But now, something was stirring deep beneath the ocean's surface. Adding to the mystery were strange seismic hums, earthquake-like tremors occurring at incredibly low frequencies, originating far below the Earth's crust. These weren't the kind of tremors you'd feel on land, but researchers around the globe detected them and linked them to unseen volcanic activity. Unbeknownst to anyone at the time, this underwater unrest was about to give birth to a giant. The eruption, hidden from view, was creating a colossal skyscraper-sized volcano. This new underwater mountain is roughly 1.5 times the height of the One World Trade Center in New York and nearly 10 times taller than the Statue of Liberty. Consider that, an entire volcanic mountain range taller than the tallest buildings on Earth, forged in secret. The area where this behemoth now stands had been surveyed in 2014. Back then, it was a flat, tranquil seabed. Now, a volcano rises nearly 8,500 feet from the ocean floor. And where does all this molten rock originate? This volcano draws its magma from a truly staggering source, a reservoir located nearly 34 kilometers underground. This is the deepest volcanic magma reservoir known to science. To understand the scale, we must delve into the Earth's structure. Our planet is layered, like a delicious chocolate. The middle layer, the mantle, is like a chunky peanut caramel filling. Research suggests that massive chunks of ancient oceanic crust are trapped deep within the Earth's liquid mantle, creating enormous lumps in what should be a smooth layer. Our planet's rigid outer layer, composed of a hot upper mantle and a fractured crust, is constantly in motion. The churning mantle causes the crust to shift, forcing oceanic crust to dive into the depths, creating massive magma plumes that rise towards the surface. Scientists have even discovered an ancient piece of the Pacific Ocean, hundreds of miles beneath China. These are the remnants of the ancient Pacific seabed, pulled downwards into the mantle transition zone. This rocky slab, once the ocean floor, consists of crust and parts of the upper mantle. Most of the Earth's volcanic activity occurs out of sight, beneath the ocean's surface. Roughly 70% of all volcanic activity takes place in the oceans, particularly in the South Pacific, where over 1,100 volcanoes are packed together. Coastal cliffs, altered mountain ranges, and sediment-filled valleys represent only a fraction of our planet's geological features. The oceans conceal so much more, hidden deep beneath the surface. Between the Earth's crust and its core lies the mantle, a warm, dense layer of rock that constantly moves and flows. Hundreds of miles below, diamonds are forged, subjected to immense temperatures and pressures before finally solidifying. When these diamonds reach the surface, scientists can study their structure, understand their formation, and gain insights into the Earth's depths. Thanks to these diamonds, scientists have discovered that the mantle is surprisingly wet, potentially containing far more water than all the Earth's oceans combined. Our planet is, in essence, consuming its own oceans. As tectonic plates shift and collide, they drag vast amounts of water into the Earth's interior. This subterranean water plays a crucial role in magma formation and can lubricate faults, increasing the likelihood of earthquakes. Water is stored within minerals, becoming integrated into the planet's crust during the formation of new oceanic plates. As these plates bend and crack under immense pressure, vast quantities of water are forced deep into the crust and mantle. Scientists studying areas 18 miles beneath the surface have discovered that these zones pull in 3 billion teragrams of water, over 2 billion pounds. The ocean is a world unto itself, teeming with hidden wonders. Beneath the surface lie breathtaking landscapes, magnificent waterfalls, expansive lakes, and meandering rivers. Thick layers of salt lie beneath the seafloor, dissolved by seawater to form underwater pools and rivers. The dissolved salt increases the water's density, causing it to settle and form these underwater lakes and rivers. But there are also underwater mountain ranges, trenches, and canyons. The canyon in the Bering Sea, with a vertical relief of over 8,500 feet, dwarfs the Grand Canyon. This underwater chasm is nearly 2,500 feet deeper than its famous counterpart. Imagine a world gripped by geological forces of unimaginable power. Our planet, a cauldron of molten rock, constantly shifting and threatening to unleash its fury. Let's journey to some of the most volatile places on Earth, where volcanoes stand as stark reminders of nature's raw strength. Picture this. For 15 relentless months, the Earth groaned and shuddered. A staggering 50,000 earthquakes were recorded. Then, in the 3 weeks leading up to the cataclysm, the frequency intensified to a terrifying 100 tremors per hour. The volcano, already active since March, was a ticking time bomb. Geologists warned that this could persist for weeks, months, years, even decades of uninterrupted eruptions. This is the reality around Mount Shasta, one of the top 5 most dangerous volcanoes in the U.S. Scientists are watching it with bated breath. Its last major eruption occurred in 1250, a distant memory. But this volcano operates on a cycle, erupting roughly every 600 to 800 years. Tick-tock, our time is coming. Now shift your perspective. Imagine yourself an hour outside Portland, Oregon. Here, another restless giant slumbers, an active volcano that last roared to life in the 19th century. Experts predict that its next outburst will unleash even greater quantities of ash and dust. The potential consequences are dire: widespread electrical blackouts, contaminated water supplies. But take heart. The scientists are diligently monitoring Mount Hood. They promise ample warning, allowing communities time to prepare and react. Across the Pacific, Kilauea, one of the most active volcanoes on the globe, has been in near-constant eruption since 1983. This makes it one of the longest-running eruptions ever documented. This is the youngest land volcano in the Hawaiian Islands. The lifespan of a volcano can vary dramatically. Some take millennia to form, while others seem to materialize overnight. Consider the case of Periquitin in Mexico. In 1943, this volcano exploded into existence in a humble open field. Within a single year, it had already soared to a height of nearly 500 feet. When the eruptions finally ceased 9 years later, the mountain stood over 9,200 feet tall, a testament to the speed and power of volcanic creation. Let's fly to Japan, home to Mount Fuji, an iconic symbol of the nation. Its last eruption occurred in 1707, showering the surrounding landscape with burning rocks as far as 60 miles away. Imagine a similar eruption today. Tokyo, a sprawling metropolis, would lie within the danger zone. Mount Fuji sits squarely on the Ring of Fire, a horseshoe-shaped region encircling the Pacific Ocean. This area is notorious for its intense volcanic and seismic activity. Stretching almost 25,000 miles, it's long enough to wrap around the Earth's equator. In January 2020, Taal volcano in the Philippines began spitting lava, sending colossal plumes of ash half a mile into the sky. The eruption even triggered a rare and awe-inspiring phenomenon: a dirty thunderstorm. This occurs when the smoke cloud above a volcano generates its own lightning. The eruption also raised the specter of volcanic tsunamis, often caused by tectonic shifts triggered by volcanic activity. Taal has erupted more than 30 times in the last 450 years. Now, consider a volcano in Ecuador. This one last erupted in 2016. Scientists are observing what they believe are early warning signs of magma movement beneath its surface. This is an active stratovolcano, a distinctive cone-shaped type with steep sides. These formations arise from viscous lava that doesn't flow easily. Instead, it accumulates around the vent, cooling and solidifying upon itself to create these precipitous walls. Stratovolcanoes are particularly prone to explosive eruptions, the kind we often see depicted in disaster movies. Journey to New Zealand, home to Tongariro National Park, a volcanic wonderland where steaming craters, magnificent lakes, and bizarre rock formations abound. Ruapihu last erupted in 2007 and has experienced 10 eruptions since the mid-19th century. But eruptions, lava flows, and toxic gases aren't the only threats posed by volcanoes. There's also the danger of lahars, volcanic mudflows consisting of debris. These mudflows can occur between eruptions when snow melts and forms a lake in the caldera. If a previous eruption deposited mud, ash, and rocks into the lake, it can become dangerously full. In such cases, only a fragile dam may hold back a catastrophic deluge. Indonesia boasts the highest concentration of active volcanoes in the world, including Anak Krakatau, meaning child of Krakatoa. Its infamous parent is not far away. A devastating tsunami in 2018 partially reawakened the offspring, a chilling prospect considering that the original Krakatoa unleashed one of the most powerful eruptions ever witnessed on this planet in 1883. Krakatoa's explosion was the loudest sound ever recorded. People over 2,000 miles away could hear the blast. The sound wave reverberated around the globe 7 times. Scientists admit that predicting this volcano's eruption patterns is a difficult task. Mount Yasur in Vanuatu is one of the few places on Earth where you can witness a lava lake up close. Tourists flock there to peer over the edge and gaze into the fiery, bubbling abyss below. However, when volcanic activity escalates to levels 3 or 4 out of 5, indicated by intensified earthquakes, volcanic tremors, or ejections of steam, gas, or ash, the area becomes off-limits. Finally, consider Nyiragongo in the Democratic Republic of Congo. This volcano harbors the most active and largest lava lake in the world. The lava is unusually fluid, allowing it to flow faster and farther than that of most volcanoes. And while Erta Ale in Ethiopia may not be among the tallest volcanoes, it possesses a unique feature: a lava lake that is almost perpetually present, a rare phenomenon. The locals call it the gateway to hell. Let's journey to distant lands, where the earth itself seems to breathe fire. We find ourselves near Erta Ale, the smoking mountain, a fitting name for this Ethiopian volcano. Its fiery lava lake is a constant source of eruptions, a spectacle of raw power. This geological giant resides near the Danakil Depression, one of the most scorching places on our planet. Imagine standing on the edge of this inferno, the air thick with heat and the smell of sulfur. Ertaol has been in a near-constant state of eruption since the mid-16th century. This makes it an invaluable natural laboratory. Scientists from around the globe flock here to study the inner workings of eruptions, seeking clues to predict these events and protect vulnerable populations. The mountain's activity offers a window into the Earth's turbulent heart. Now, picture a seemingly peaceful landscape in central Mexico. After a period of dormancy, Popocatépetl, a volcano of considerable size, roared back to life in 1994. Since then, it has unleashed massive mudflows and violent explosions, their timing as unpredictable as the Earth's own heartbeat. In the distant past, colossal eruptions from this sleeping giant buried entire cities and even pyramids under layers of ash and rock. A chilling reminder of nature's capacity for destruction. Envision yourself as a traveler, waking in a hotel room to a breathtaking yet terrifying view. A massive volcano dominating the horizon, its slopes covered in glowing rivers of molten lava, a plume of ash rising into the sky. This is the spectacle offered by some of Earth's most active volcanoes. In Guatemala, near the Volcán de Pacaya, visitors take a unique opportunity to experience the volcano's heat firsthand. They roast marshmallows over the hot volcanic rocks, a surreal picnic on the edge of a geological furnace. Our journey continues to a small island north of Sicily, where Stromboli, one of Earth's most active volcanoes, puts on a regular show. Explosions punctuate the sky, accompanied by streams of glowing lava that pour from vents within its crater, a constant reminder of the forces churning beneath our feet. Not far from Stromboli rises Etna, Europe's most active and one of the largest continental volcanoes in the world. Its immense size and frequent eruptions make it a geological force to be reckoned with, shaping the landscape and influencing the lives of those who live in its shadow. But Earth isn't the only volcanic world in our solar system. Let's venture to Mars, where Olympus Mons, the largest volcano in the solar system, resides. Its scale is almost unimaginable. This giant would cover the entire state of Arizona and towers nearly 3 times higher than Mount Everest, a truly awe-inspiring testament to the power of planetary forces, a landscape sculpted by fire and time. Venture into the crushing depths of our planet's oceans, where a truly alien world awaits. Here, far beyond the reach of sunlight, the water remains perpetually cold, hovering around a frigid 4 °C. But descend further still, to the very floor of the ocean, and an astonishing paradox emerges. Temperatures can soar to scalding levels. Imagine the seafloor riddled with hydrothermal vents, underwater hot springs situated along the volatile edges of tectonic plates. These vents spew forth superheated water, reaching an incredible 400 degrees Celsius. The pressure at these depths is immense, so extreme that no human could survive. Yet it is this very pressure that prevents the water from boiling, creating an environment unlike any other on Earth. The average depth of the ocean is a staggering 3,700 meters. Sunlight penetrates only a fraction of this distance. A mere glimmer reaches down to 1,000 meters, leaving the vast majority of the ocean in perpetual darkness. The truly illuminated zone extends down to a paltry 180 meters. Even with the life-giving light of the sun, most of our planet remains shrouded in blackness, thanks to the oceans that cover over 70% of the Earth's surface. Now, picture this. The loudest sound ever recorded on our planet originated from the ocean. It wasn't a volcanic eruption or a colossal whale, but an icequake. This deafening roar, caused by a massive fracture in the ice, was so intense that researchers detected it with sensors over 4,800 kilometers away. The seismic activity triggered a catastrophic breakdown of frozen ground. Consider the sheer scale of Antarctica. Its ice sheet is larger than the continental United States and Mexico combined. A single large iceberg breaking off from Antarctica can contain over 75 billion liters of water, enough to supply 1 million people for 5 years. Intriguingly, humans can, in certain circumstances, drink sea ice. While seawater itself is too salty for consumption, the freezing process naturally expels much of the salt. As the ice ages, the brine trapped between the ice crystals drains away, leaving behind ice that is fresh enough to drink. But what if all the ice on Earth, the ice sheets and glaciers, were to melt simultaneously? The sea level would rise by approximately 80 meters. That's almost the height of the Statue of Liberty, or a 26-story building disappearing beneath the waves. The secrets of our oceans are not just locked in the water, but also within the creatures that dwell there. Take clams, for example. These seemingly simple mollusks can live for centuries, offering invaluable insights into the ocean's past. Just as tree rings reveal a tree's age and history, the rings within a clam's shell can tell us about ocean climate, temperature fluctuations, and environmental conditions dating back over 1,000 years. In a recent development, the Earth's oceans have been reclassified. We now recognize not 4, but 5 oceans. The newly designated Southern Ocean, officially recognized just months ago, surrounds Antarctica and borders the Atlantic, Pacific, and Indian Oceans. For years, scientists debated whether it was a distinct ocean or simply the colder regions of the other 3. Each ocean boasts unique conditions that support specialized marine life. The Southern Ocean, for instance, is home to iconic creatures like leopard seals, orcas, Orcanis orca, minke whales, Balanoptera, Acuta and emperor penguins, Aptenodytes forsteri, all adapted to the frigid, icy waters. It's also a vital habitat for krill, tiny shrimp-like crustaceans that form the base of the food chain for many larger animals. Now, let's journey back billions of years. Life on our planet originated approximately 3.5 billion years ago. The exact how and when remains a mystery, but one prevailing theory suggests that life first emerged in the deep ocean. Recent discoveries have lent credence to this idea. Scientists have found microscopic tubes and filaments within rocks formed around 4 billion years ago. These rocks are fragments of ancient oceanic crust. Intriguingly, these tiny structures bear a striking resemblance to microbes found today near hydrothermal vents in the deep ocean. The hypothesis is that these early living cells found refuge and sustenance within the porous rock formations surrounding the vents, igniting the incredible saga of life's evolution on Earth. Switching gears, imagine the immense power lurking beneath Yellowstone National Park. This seemingly idyllic landscape sits atop a colossal supervolcano, the reason for its famous geysers and hot springs. Beneath the surface lies an enormous magma chamber. In 2015, researchers discovered that this chamber was even larger than previously believed, and they even identified a second, deeper reservoir of magma. Combined, these reservoirs hold enough magma to fill the Grand Canyon 11 times over. Perhaps most concerning is the fact that these magma chambers exert pressure on the ground above. As a result, the land in Yellowstone rises by several centimeters each year. Furthermore, Yellowstone is classified as an active volcano with a volcanic explosivity index of 8 out of 8. This rating signifies that a major eruption would be an apocalyptic event. To put this into perspective, the 1991 eruption of Mount Pinatubo in the Philippines, considered the most powerful in recent memory, was rated a 6 on the same index. So, should we be worried? Imagine, if you will, the vast expanse of Yellowstone National Park. Now, let's rewind the clock to March 2023. Beneath the serene landscape, a hidden drama unfolded. The University of Utah seismograph station meticulously recorded a staggering 354 earthquakes rippling through the region. A number that might sound alarming, but let's delve deeper. The star of this seismic show was a modest magnitude 3.7 earthquake. It wasn't a solitary tremor, but rather part of a swarm, a cluster of 106 earthquakes that began on March 29th and persisted until the month's end. Yes, earthquakes, much like many other natural phenomena, can occur in swarms. Experts assure us that Yellowstone's seismic activity, while elevated, isn't cause for panic. Michael Poland, a geophysicist at the Yellowstone Volcano Observatory, confidently states that an eruption is not imminent. For a volcano to erupt, two critical conditions must be met: a substantial reservoir of magma ready to burst forth from beneath the surface, and sufficient pressure to force that magma upwards. According to Poland, neither of these conditions are currently present. Yellowstone, for now, remains stable. However, Poland and his team remain vigilant. They continuously monitor the subterranean realm for any telltale signs of an impending eruption. These warning signals include the frequency of earthquakes and ground deformation. A surge in minor earthquakes, coupled with drastic alterations to the ground surface, would certainly raise alarms. The team also keeps a close watch on the temperature of the park's thermal features. Park-wide changes in geyser activity, as well as gas and thermal emissions, are all noteworthy indicators of potential volcanic unrest. Despite media speculation fueled by the 70,000-year gap since Yellowstone's last eruption, experts emphasize that volcanoes don't adhere to predictable timelines. This notion of regular eruption intervals is a common misconception. Now, let's consider a hypothetical super-eruption. The immediate threats wouldn't be lava flows or the accompanying earthquakes. The true danger lies in the ash, a colossal ashfall that would blanket the surrounding landscape. To truly grasp the potential impact, let's journey back in time to witness Yellowstone's past eruptions. Throughout its history, this volcanic region has experienced at least 3 super-eruptions. The most cataclysmic of these events unleashed a force 2,500 times greater than the devastating 1980 eruption of Mount St. Helens in Washington state. The most recent super-eruption, known as the Lava Creek eruption, sculpted the very landscape of Yellowstone, forming the Yellowstone caldera. It ejected an unimaginable volume of dust, volcanic ash, and rock into the atmosphere. More recently, scientists have uncovered evidence of 2 previously unknown super-eruptions that occurred approximately 9 and 8.7 million years ago. The younger of these 2 is now considered the largest recorded event within the entire Snake River Yellowstone volcanic province. But what exactly transpired during those distant epochs, millions of years ago? Since eyewitness accounts are unavailable, we must rely on scientific evidence to reconstruct these events. The signs of impending disaster manifested long before the actual eruption. For millennia, heat had been relentlessly building within the Earth's interior, melting rock beneath the crust and creating vast chambers. These chambers became reservoirs of pressurized semi-solid rock, magma, water vapor, and various gases, including carbon dioxide. This scorching subterranean soup expanded as more and more magma accumulated. The land above the volcanic system gradually rose upward, almost imperceptibly. A year before the super eruption, Yellowstone issued a warning, a geological burp, if you will. But in that era, there was no one to interpret these subtle signals. Furthermore, these alarming processes were largely unfolding beneath the surface. For instance, decompression released gas bubbles. The bursting of these bubbles can often fuel particular types of eruptions. Months before the eruption, small-scale earthquakes became more frequent and intense. The ground in many areas of the supervolcano became hotter than usual. Surface lakes and groundwater also warmed up. Had humans been present, they would have noticed unusual steam rising from the ground. Shortly before the eruption commenced, the escalating pressure pushed the ground above the magma chamber upwards, forming a dome-shaped uplift. Narrow cracks began to appear along the edges of this dome. Imagine the moment you open a soda bottle after vigorously shaking it. A similar phenomenon was unfolding near the volcano. The pressure was released through these fractures as gases burst forth from beneath the surface. In the moments leading up to the cataclysm, the ground surrounding the Yellowstone volcano lifted. Geothermal pools and geysers heated to boiling temperatures and became more acidic than usual. The magma began its ascent towards the surface. At one point, the earth groaned, a deep, unsettling tremor that signaled the beginning of the end. The magma chamber, stretched to its absolute limit, could no longer contain the molten fury within. The eruption began, not with a bang, but with a series of small, persistent shudders that ran through the ground days before the true catastrophe. These were the harbingers of doom, the whispers before the scream. But the real terror didn't begin until mere minutes before the full eruption. Then, with a deafening roar that ripped through the very fabric of the earth, a colossal column of lava and ash was violently ejected into the atmosphere. Imagine a geyser of hellfire spewing forth from the bowels of the planet. Within moments, a pyroclastic flow, a searing wave of death, surged across the landscape at speeds rivaling a hurricane. This wasn't just lava. It was a superheated slurry of semi-solid lava fragments, volcanic ash, and explosively expanding gases. Picture a toxic avalanche of unimaginable heat, a white-hot blizzard of destruction. With temperatures soaring to a staggering 1,300 degrees, it incinerated everything in its path. For days, the volcano relentlessly pumped ash into the atmosphere. For any living creature caught beneath this rain of fire, the ashfall was a death sentence. Volcanic ash, upon inhalation, quickly transformed into a glassy, cement-like substance within the lungs. Most animals stood no chance. Even the mightiest trees, ancient sentinels of the forest, began to buckle and collapse under the immense weight of this suffocating substance. Within days, a thick, suffocating blanket of ash had enveloped vast territories. But the devastation didn't end there. As the ash ascended into the stratosphere, global temperatures began to plummet. The eruption released massive quantities of sulfur, an incredibly effective sunblocker. Soon the world was plunged into an artificial winter, a prolonged period where summer simply ceased to exist. For years, animals struggled to find food and clean water, teetering on the brink of extinction. This cataclysmic event, known as the Gray's Landing supereruption, was, as researchers have described in their studies, truly colossal. It impacted a vast area. Rivers of lava transformed a region the size of New Jersey into a desolate wasteland of scorching volcanic glass, instantly sterilizing the land and obliterating the thriving plant life that had once flourished there. Consider this. If a similar eruption were to occur today, it would bury Colorado, Utah, and Wyoming under nearly 3 feet of toxic volcanic ash. Imagine entire regions plunged into perpetual darkness. Even coastal areas, home to a significant portion of the American population, would face unimaginable challenges from the spreading ash cloud, which would decimate crops, contaminate pastures, and cripple power grids and electrical transformers. It's a chilling prospect, isn't it? A stark reminder of the raw, untamed power that lies dormant beneath our feet. Thankfully, such a disaster is not expected anytime soon. But imagine this. The ground beneath you begins to tremble. Pictures rattle on the walls. A low rumble echoes in the distance. Then, a deafening boom. A definite explosion. The shockwave blasts through your windows, setting off car alarms. You instinctively dive under the dining table for cover. But then, a chilling realization. You live not far from a supervolcano, nestled in the heart of a tropical jungle. Staying put is not an option. The shaking eventually subsides. You cautiously peek outside. A colossal cloud of smoke chokes the sky, blotting out the sun. It's lunchtime, but the world is shrouded in an unnatural twilight. The power grid has failed, plunging the entire city into darkness. And in that darkness, you see it. Red, molten lava, arcing through the sky, spilling over the volcano's rim. You surge outside, joining dozens of your neighbors in a desperate flight for survival. Your immediate priority? Find safe shelter, and find it fast. You briefly consider the car, but the roads are already choked with panicked citizens. Foot it is. You run, swept along with the terrified crowd. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not just about sheer size or height. A volcano earns the super designation if it erupts more than 240 cubic miles of magma, enough to drown Lake Erie. It must also have a history of cataclysmic eruptions and register a magnitude of 8 on the Volcanic Explosivity Index. Consider Mauna Loa in Hawaii, the largest active volcano on Earth. It's so immense that it could swallow the entire state of Rhode Island, with room to spare. Next time you see a commercial plane soaring at 30,000 feet, remember that's roughly the height of Mauna Loa, from its base to its summit, technically taller than Mount Everest when measured that way. Yet, Mauna Loa is not classified as a supervolcano. Back in the imagined eruption, you're running blindly down the darkened road, barely able to see where you're going. Suddenly, a massive, flaming boulder crashes through the bridge ahead, cutting off your escape route. You and everyone else are now stranded on the volcano's flank as chaos intensifies with each passing second. The crowd begins to fragment, each person desperately seeking their own path to safety. But you remember a little-known route to the other side, a treacherous path that requires crossing a raging river through the dense jungle. You rally the remaining members of the crowd, instilling what little calm you can muster. They follow you, placing their trust in your knowledge. Finally, you break free from the city limits and plunge into the jungle. With the sky already blacked out by ash, the towering trees and dense foliage create an almost impenetrable darkness. Everyone activates their phone flashlights, creating a flickering constellation of light to guide your way. You must stick together, ensuring no one is left behind in this desperate flight for survival. Suddenly, all hell breaks loose. Imagine the scene. Fiery projectiles, ripped from the belly of the earth, slam into the trees around you. The force throws you and everyone nearby off balance. Panic sets in as people scramble forward, desperate for escape. But there's nowhere truly safe when the sky is raining down molten rock. Your group, a collection of ordinary people thrust into extraordinary circumstances, knows they must move faster or face a fiery demise. Envision a typical avalanche or a mudslide, terrifying events in their own right. Now, amplify that danger tenfold. Picture an avalanche of lava rocks, rivers of molten lava cascading down the mountainside. That's the nightmare bearing down upon you now. More survivors, their faces etched with terror, join your group, bringing grim tidings. The entire neighborhood, they report, is now submerged beneath a sea of lava. The molten rock is moving faster than anyone anticipated. Predicting the speed of a lava flow is a fool's game until you witness it firsthand. It all hinges on the lava's viscosity and the steepness of the terrain. Lava can creep along at a mere 20 feet per minute, a snail's pace compared to a human's walking speed. Or it can surge forward at a blistering 30 miles per hour, a speed that would leave even the world's fastest sprinter in the dust. But the lava itself isn't the only or even the most immediate threat. Without protection, the toxic gases belching from the volcanic eruption would swiftly overwhelm your lungs. These invisible killers spread faster and farther than the lava flow itself. Your eyes and throat would burn with unbearable itching. A splitting headache would pound in your skull, accompanied by dizziness and a racing heart. Breathing would become a desperate struggle. The worst-case scenario? Loss of consciousness due to oxygen deprivation. Thankfully, everyone managed to grab their gas masks before fleeing their homes, a decision that may have saved their lives. Now, you find yourselves entering the treacherous embrace of the jungle, a danger zone where every shadow holds a potential threat. One by one, cell phone batteries are dying, plunging you further into darkness and uncertainty. The already challenging terrain becomes even more difficult to navigate. The roar of the river, your guiding beacon, fades into silence. You're no longer certain if you're heading in the right direction, but your instincts scream that the deeper you venture into the jungle's heart, the safer you'll be. The path ahead is a quagmire of mud, and thick vines snag at your limbs, hindering your progress. Suddenly, a sound pierces the air, the unmistakable thunder of something massive crashing through the undergrowth. It's bearing down on you with alarming speed. Visibility is near zero, and you can't see a thing until it's practically upon you. A bear bursts from the trees, followed by a rhino, their eyes wide with panic. Wildcats, domestic cats, dogs, a chaotic menagerie of creatures of all shapes and sizes, all fleeing the same terrifying threat. You and your fellow humans aren't the only ones desperate to escape the eruption's wrath. The ground continues to tremble, a constant reminder of the cataclysm unfolding around you. Without warning, a fresh barrage of fiery rocks rains down, igniting sections of the jungle behind you. There's no turning back now. Everyone surges forward, driven by primal fear. In the distance, the rumble of thunder echoes through the sky. A flash of lightning illuminates the darkness, offering a fleeting glimpse of hope. Could it be rain finally to wash away this fiery nightmare? But this is no ordinary storm. The colossal smoke clouds billowing from the volcano can mimic a thunderstorm, creating a false promise of relief. Then, a stroke of luck. You hear the sound of the river, your destination, directly ahead. You reach the bank and begin to hop across the slippery stones, your heart pounding in your chest. A misstep sends you stumbling, but a strong hand from someone in the group catches you just in time, preventing a potentially fatal fall. That was far too close. Not far downstream, a large waterfall plunges into a shallow lake, its bottom littered with jagged rocks. The ash from the eruption falls like an eerie snow, blanketing the trees and coating the river's surface. Ash is one of the most insidious dangers of a volcanic eruption. You're soaked to the bone, but it's a far better fate than choking on ash and smoke. The rest of the group follows, their faces grim but determined. Then, the unthinkable happens. The river begins to steam as molten lava reaches the bank and spills into the water. You urge everyone to move faster, knowing that the lava can rapidly heat the water to scalding temperatures. People are still struggling to cross the treacherous rocks, their movements slow and uncertain. Miraculously, you manage to get everyone across. Almost everyone. You turn back and see a horrifying sight. Someone's leg is trapped between two rocks, the rising waters threatening to engulf them. The lava continues to pour into the river, the heat radiating off the water in palpable waves. Without hesitation, you rush back to the trapped individual, desperately trying to free their leg. It won't budge. Another member of the group joins you, and together with a final surge of adrenaline, you manage to pull them free just in the nick of time. You and the rest of the exhausted survivors press onward, driven by the desperate need to escape. Finally, you spot it. The main road, your connection to the outside world, to safety. You see other survivors on the road, some already piling into cars, desperate to flee the disaster zone. The volcano continues to spew lava, a fiery testament to its destructive power. What was once your town now resembles a vast, burning lake, a scene of apocalyptic devastation. Planes and helicopters are grounded, unable to navigate the thick smoke and ash. Don't count on an air rescue. You're still at risk, even on what seems like safer ground. It's far too early to celebrate. Everyone continues to move away from the city, putting as much distance as possible between themselves and the eruption. The ground trembles once more, but this time the shaking is even more violent than before. Supervolcanoes possess the power to trigger massive earthquakes, capable of leveling entire cities. But at least you're out in the open, far from buildings and debris, giving you a slightly better chance of survival in this unfolding catastrophe. Let's leave the hustle of modern cities behind and journey back to a time almost beyond comprehension. But rest assured, the cataclysmic volcanic events we're about to explore are unlikely to repeat themselves anytime soon. We're talking millions of years. Moreover, thanks to advanced warning systems and humanity's preparedness, even a regular volcanic eruption is far less likely to cause widespread devastation than it once could. So, don't cross Yellowstone National Park off your travel list just yet. Now picture this: Kawah Ijen volcano in Indonesia. This isn't your typical fire-breathing mountains spewing black smoke and red-hot lava. This geological oddity puts on a dazzling display of blue flames and electric blue lava. This remarkable phenomenon occurs because the volcano contains exceptionally high levels of sulfur. When these sulfuric gases interact with the scorching air and are ignited by the molten lava, they burn with an otherworldly blue glow. Sadly, this mesmerizing spectacle is best viewed at night, but you can certainly smell it all day long. And while we're on the subject of unique landscapes, consider this. Within the crater of Kawah Ijen lies the world's largest acid lake, a truly hostile environment. Shifting continents now, our next stop is the Dead Sea. This ancient body of water possesses a salt and mineral concentration far exceeding that of ordinary seas. So extreme, in fact, that swimming becomes nearly impossible. You simply float. People flock here for the therapeutic natural chemicals and the sheer relaxation of effortlessly bobbing on the surface. The Dead Sea earned its ominous name because no macroscopic organisms can survive in its intensely saline environment. It's roughly 9.6 times saltier than the oceans. Only a few specialized bacteria and fungi dare to call this place home. It also marks Earth's lowest land elevation, plunging to approximately 400 feet below sea level. Now, imagine descending deep beneath the surface to a place where sunlight never penetrates. Here, in Mexico, lies an underground crystal cave, a surreal landscape that seems ripped from a science fiction film. Roughly 1,000 feet below ground, colossal crystal spikes, some measuring up to 36 feet in length and weighing a staggering 55 tons, jut out in all directions. These are among the largest crystals ever discovered on our planet. Let's travel to Scotland and the seemingly tropical Luscantire Beach. An endless expanse of white sand dunes kissed by azure waters. Don't be fooled by the apparent tropical vibe, though. This is Scotland. This scene is most commonly found in May and June. In December, this location gets only an average of 1 hour of sunshine per day, making the landscape more dramatic and monochrome. Our journey takes us next to the Georgia Guidestones, a mysterious monument composed of giant stones arranged in a star pattern. Inscriptions in 8 different languages, including Hindi, Chinese, and Swahili, adorn the stones. An astronomical calendar is built into the structure. Completed in 1980, the Guidestones' purpose and the identity of their builders remain shrouded in mystery. From the enigmatic stones of Georgia, we head west to sunny California, home to Sequoia National Park and its awe-inspiring giant forest. These majestic trees have stood for thousands of years, with over 8,000 colossal sequoias dominating the landscape. Among them stands General Sherman, estimated to be up to 2,700 years old and recognized as the world's largest known living tree by volume. A true titan of the plant kingdom. Across the Pacific, on the remote Easter Island, stand the iconic stoneheads, silent sentinels of a bygone era. For hundreds of years, these massive statues have captivated the world. The exact reason for their construction remains a subject of debate. Some scientists believe the local people believe the statues would make the soil more fertile, and soil analysis proves the heads did their job well. It's the best agricultural spot on the island. In Pamukkale, Turkey, ancient hot springs cascade over the edge, creating a magical, otherworldly landscape. The unique chemical composition of the water gives it a milky white appearance, and the thermal waters are believed to possess therapeutic properties, cleansing both body and mind. Venturing into the Arabian Peninsula, we find Al-Nasla, a remarkable rock formation in Saudi Arabia. What makes Al-Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Finally, we arrive in Antarctica, where bloodfall stains the pristine white landscape a shocking red. This eerie phenomenon is the result of extremely salty water, rich in iron oxide, flowing from beneath the Taylor Glacier. The iron oxidizes upon contact with the air, creating the blood-like appearance that gives the falls their name. In early May 2018, New England faced one of the scariest and most dangerous weather phenomena: a super-long track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the third on the list of the longest track tornadoes in New England. Let's travel to the Philippines, where you can swim in some of the most crystal-clear waters and discover an underwater world below you. In the province of Palawan, the municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Finally, we venture to Tristan da Cunha, a remote volcanic archipelago in the South Atlantic. The nearest cities are Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Imagine, a sight so bizarre, so out of place, it defies belief. Picture the Atlantic Ocean, specifically off the coast of North Falmouth, Massachusetts. Now, envision it utterly, completely frozen. Not just a thin layer of ice, but a solid expanse so thick that people are strolling across the waves. A truly uncommon spectacle, something you wouldn't witness in your everyday life. Then, let's journey to the shores of Tianjin, China. Here, a beach unfolds in a vibrant, unexpected hue. Red. Red sand stretches as far as the eye can see, a magnet for curious tourists. The secret lies in a unique plant, the Sueda salsa, thriving in the salty water. This crimson vegetation paints the entire beach in shades of red, leaving only the shimmering surface of the sea untouched. And what about structures that challenge the very laws of physics? Consider the stone of Damasco in Argentina. This isn't just a rock, it's a colossal 300-ton boulder perched precariously on the edge of a cliff. It teeters ever so slightly, swaying gently in the wind. Locals even tested its balance, placing glass bottles beneath its edges, only to see them shatter with each subtle movement of the massive stone. Alas, this natural wonder is no more. In 1912, after standing sentinel for centuries, the boulder plunged from its lofty perch. The inhabitants of nearby Tandil mourned its loss. As a tribute, 95 years later, in 2007, they erected a plastic replica on the very same spot, mimicking its original position. Today, visitors to Tandil can still marvel at the famous balancing boulder, now a symbol rather than a precarious marvel, weighing a mere 9 tons. But its iconic shape remains instantly recognizable. Now, let's set our sights on Socotra, a remote island off the coast of Yemen, adrift in the Indian Ocean. This place feels alien, otherworldly. It is home to one of the most peculiar trees on Earth, the dragon tree. Its umbrella-shaped canopy and blood-red sap are unique to this isolated island. In 2008, its ecological significance was recognized when it was designated a World Heritage Site. What should you do if you ever encounter a towering column of burning air, spiraling and intense? Don't panic. It's not the apocalypse. This terrifying combination of roaring winds and searing heat signifies a fire tornado, also known as a fire whirl or fire twister. This dangerous phenomenon most often occurs during raging wildfires. The intense heat from these fires creates a vast zone of superheated air close to the ground. When this scorching air collides with cooler air higher up, it generates a whirlwind effect, violently churning up burning debris and flames. The most powerful fire tornadoes can reach hundreds of feet into the atmosphere. Venture to Gold Hill, Oregon, and you'll find the House of Mystery, a place that defies the natural order. Inside, visitors struggle to stand upright, constantly leaning and grasping for balance. Balls inexplicably roll uphill. A broom, defying gravity, stands perfectly still wherever it's placed, unlike anything else within the shack. Long before the house was built, local Native American tribes considered this ground forbidden, avoiding it altogether. The owners, however, saw an opportunity. They transformed it into an attraction, cultivating an aura of mystery and spreading tales through newspapers, and later, the internet. The result? A perfect anomaly, or so it seems. In reality, it's a cleverly crafted optical illusion, a human-made curiosity that plays tricks on your eyes and other senses. If you find yourself in the Philippines, Indonesia, or Papua New Guinea, prepare to encounter some of the most cheerful and unusual trees in the world. The rainbow eucalyptus, Eucalyptus deglupta, boasts a trunk that looks as if it has been painted with every color imaginable: orange, green, red, purple, yellow, brown, and blue. Some trees are so vibrant they appear artificial. The rainbow eucalyptus regularly sheds strips of its bark, revealing a bright green layer underneath. Over time, this green layer gradually transforms, shifting through a spectrum of colors. Because the shedding occurs at different times and in different locations on the trunk, the tree develops a mesmerizing multicolored appearance. Yemen is also home to some of the oldest skyscrapers and metropolises on Earth. The ancient city of Shibam, a collection of mud brick buildings rising dramatically from the desert floor, is often referred to as the Manhattan of the desert. In ancient times, it served as a crucial caravan stop, a testament to its historical significance. Finally, if you've ever visited Yellowstone National Park, you've likely been captivated by its geysers, erupting with superheated water and steam. But even more intriguing is the hidden network beneath your feet, the vast underground plumbing system that fuels these spectacular eruptions. Recently, researchers successfully mapped Yellowstone's hydrothermal plumbing system using a giant airborne magnetometer. This allowed them to document these subterranean features in unprecedented detail. Yellowstone boasts the world's largest hydrothermal system, encompassing over 10,000 features, including geysers, mud pots, hot springs, and steam vents. All are interconnected by a complex network of underground water pathways, superheated by magma flowing beneath the surface. Imagine a hidden world beneath our feet, a subterranean realm of scalding water and molten rock. We're talking about Yellowstone, a place of incredible natural beauty, but also a place of profound geological mystery. For years, scientists have been piecing together the puzzle of what lies beneath the surface, and new tools are finally giving us a glimpse into the unknown. One of the biggest challenges is understanding Yellowstone's hydrothermal system. This is the network of underground water that feeds the geysers and hot springs, causing water to surge to the surface in spectacular displays. The intricacies of this system remain largely unknown, but recent mapping efforts are beginning to shed light on its workings. Experts describe our current understanding of Yellowstone as a mystery sandwich. We know a lot about the surface features because we can see them. We also understand the deep magmatic and tectonic systems miles below. But the middle layer, the plumbing that connects the two, has remained a mystery until now. Enter the SkyTem project, a giant flying magnet used for groundbreaking research. Imagine an 82-foot wide loop of charged wire suspended from a helicopter soaring over Yellowstone. This device generates a powerful electromagnetic field, scanning the ground below. Different materials, like water and rock, respond to this field in unique ways. By analyzing these responses, scientists can create detailed subsurface maps, revealing hidden structures and processes for the first time. This mapping technique allows researchers to distinguish between magma and bedrock thanks to their slightly different magnetic properties. The team can now observe how magma and water interact, creating the mind-blowing geological features we see on the surface. The SkyTem project has produced high-resolution maps to a depth of 2,300 feet and lower-resolution maps reaching down 1.5 miles. But the hydrothermal system itself may extend as far as 3 miles below the surface. If that's the case, we've only mapped the top half of Yellowstone's plumbing. Remember the bottom layer of the mystery sandwich? Scientists have a good grasp of the tectonic plates and deep fault lines, largely due to the frequent earthquakes that rattle the park. These tremors provide invaluable data for studying subsurface phenomena. In July 2021 alone, over 1,000 earthquakes shook the Yellowstone area. Through this constant seismic activity, researchers are learning more about iconic features like Old Faithful Geyser and the Grand Prismatic Spring. They've even discovered that individual hydrothermal features on the surface can be connected to others as far as 6 miles away. Another fascinating revelation is that despite the vast differences in size, shape, color, volatility, and chemical composition of Yellowstone's geysers and hot springs, they are mostly fed by very similar underground sources. This means that the unique characteristics of each feature arise closer to the surface, shaped by local conditions and interactions. And what about that iconic image of Yellowstone, the Grand Prismatic Spring, a vast pool of water ringed with fiery orange hues? What creates these stunning colors? Surprisingly, the answer lies in microscopic life. The temperatures in these springs are incredibly high, hot enough to cook you in an instant. The water is also highly acidic, like the fluid in a car battery. Yet, certain types of heat-loving microbes thrive in these extreme conditions. Each ring of color represents a zone inhabited by different bacteria, each species adapted to a particular temperature and pH level. Consider the Grand Prismatic Spring. Its rainbow hues are a testament to the incredible diversity of microbial life. The center of the spring boasts a beautiful aquamarine color, where the water temperature reaches a scorching 189 degrees Celsius. This area is directly above the underground water source, making it too hot even for the hardiest microbes. The blue color, like the blue of the sky, is due to the scattering of sunlight as it hits the water's surface. Moving outward, the next ring of color is yellow, thanks to the presence of certain cyanobacteria. The temperature in this ring is a slightly cooler 165 degrees Celsius. Under different conditions, these bacteria would produce a blue-green hue due to chlorophyll. However, the intense sunlight forces them to produce another pigment called carotenoids. This pigment acts as a sunscreen, protecting the bacteria from the harsh rays. Since carotenoids are orange, the normally green bacteria take on a yellowish tint. Finally, we arrive at the bright orange color near the edges of the prismatic spring. Here, the temperature is around 149 degrees. In this zone, we find several types of... Imagine a place of vibrant color and immense power. Yellowstone National Park. Here, the very earth breathes, and the ground beneath our feet whispers tales of unimaginable forces. Let's journey to the heart of Yellowstone, where we find hot springs teeming with life. Microscopic life, that is. These aren't your average puddles. They are cauldrons of geothermal activity, home to countless species of bacteria. These bacteria are the artists of Yellowstone, painting the springs in a dazzling array of colors. They all manufacture substances that give the springs that vivid orange hue. But on the edges, where the temperature drops to a more moderate 131 degrees Fahrenheit, a greater diversity of microbes thrives. Together, they create the red-brown border that frames these natural masterpieces. But here's a sobering thought. Human activity may be altering these delicate ecosystems. Take Morning Glory Pool, for example. It used to boast a deep, mesmerizing blue, a testament to its intense heat. But over time, trash accumulated, clogging the vent that fed the pool. The result? Temperatures plummeted, allowing different microbes to flourish. The once pristine blue transformed into a mix of orange and yellow. And what about Old Faithful, the geyser that has captured the hearts of generations? It earned its name in the late 19th century, a tribute to its remarkably consistent eruptions. More active than its neighbors, Old Faithful puts on a show approximately 20 times each day. Picture this: a towering fountain of scalding water, propelled skyward for 1 to 5 minutes, reaching heights of up to 180 feet. Of course, no discussion of Yellowstone is complete without acknowledging the sleeping giant beneath our feet. The Yellowstone supervolcano. These colossal volcanoes form when vast quantities of magma struggle to escape from the Earth's depths. Sometimes the magma encounters an impenetrable barrier, becoming trapped beneath the surface. Over millennia, immense pools of pressurized magma accumulate just a few miles below. As more and more molten rock attempts to ascend, the pressure intensifies. Eventually, the inevitable occurs: a super eruption of unimaginable scale. You definitely wouldn't want to witness that firsthand. In the last half-century, the Yellowstone caldera has risen nearly 3 feet, but don't panic. Experts assure us that this is simply part of Yellowstone's natural rhythm. Periods of uplift are followed by periods of subsidence as the caldera settles. Scientists currently believe that the supervolcano poses no immediate threat. For an eruption to occur, the magma within must be at least 50% molten. In Yellowstone's case, that figure is a mere 5 to 15%. In fact, a recent study suggests that the hotspot may even be entering a period of decline. Despite this reassuring news, it's important to remember that Yellowstone has a history of cataclysmic eruptions. There have been at least 3 other super eruptions in Yellowstone's past, occurring 2.1 million, 1.3 million, and 640,000 years ago, long before humans even walked the Earth. The most recent of these, known as the Lava Creek eruption, sculpted the Yellowstone caldera, unleashing a staggering 240 cubic miles of rock, dust, and volcanic ash. Now, let's shift our focus to a more recent event. On Friday, March 19, 2021, at 8:45 p.m., about 20 miles southwest of the Icelandic town of Grindavik, the Earth groaned and split open. Molten rock burst through the surface, and brilliant lava fountains illuminated the night sky. A volcano in this valley had awakened after nearly 800 years of slumber. Volcanoes are generally categorized into 3 groups: active, dormant, and extinct. Around the world, roughly 1,900 volcanoes are considered active, meaning they have erupted in the recent past and are likely to do so again. Dormant volcanoes, on the other hand, haven't erupted for a long time, but they still possess the potential to awaken. They are, in essence, sleeping giants. Extinct volcanoes, as the name suggests, haven't shown any signs of life in over 1 million years. Fortunately, the Icelandic eruption was not particularly explosive, and it occurred 6 miles from the nearest town, ensuring everyone's safety. Many people even came to witness the spectacle up close. Some adventurous souls even attempted to cook eggs and bacon on the molten rock. Just be careful not to burn your breakfast. Black lava can reach temperatures exceeding 2,000 degrees Fahrenheit, incinerating everything in its path. Yet paradoxically, it also creates some of the most fertile land for agriculture. This particular eruption initially produced a relatively small amount of lava, but it has been spreading across the valley, forming a growing shield of molten rock. Predicting the speed of a lava flow is a challenging task. It depends on the lava's viscosity and the steepness of the terrain. Lava can ooze along slowly at about 20 feet per minute, slower than an average person's walking speed. Or it can surge at speeds of up to 30 miles per hour, outpacing even the fastest human on Earth. But the lava itself isn't the only danger posed by volcanoes. Toxic gases released during eruptions can be even more perilous, spreading faster and farther than the lava flow. Fortunately, in the case of the Icelandic eruption, the wind carried these gases away from residential areas. Scientists weren't surprised by this eruption. They had been anticipating it. Increasingly intense earthquakes had been shaking the region for weeks, a clear sign that something was brewing beneath the surface.